Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast, the podcast where I find out more about what Microchip does across all their different divisions. Today, my guest is Bob Vampola. Bob is the Vice President of Aerospace and Defense at Microchip. Bob, can we start off and just to learn a little bit about your role at Microchip?
Sure, Mike. My role at Microchip is right now I'm the Vice President of Aerospace and Defense. I'm basically leading a team that's responsible for growing Microchip brand recognition in the aerospace and defense markets. We basically work to bring innovative products into the market. We work to have key agency relationships and ultimately helping to drive the strategic client engagements. So I actually came to Microchip via the Microsemi acquisition back in 2018.
Oh, that's great. It's great you're on board with Microchip now. You talk about aerospace and defense, but I think actually you'd split that into three markets. Is that right?
Yeah, we look at three sub-markets within the aerospace and defense sector. So if you look at those three markets, we break them down into commercial aviation, space, and defense. In commercial aviation, we're really looking at things like avionics and actuation, RF, microwave systems, engine systems, basically in the commercial aircraft. From space, it goes from commercial satellites, military, telecom. It also includes launch vehicles for us and even strategic weapons. But from a space standpoint, really looking at the low Earth, mid-Earth, and geosynchronous type orbits. In the defense segment, we support applications such as EW or electronic warfare and radar, secure comms, guidance and control. Infrared imaging is a hot area as well, embedded computing. And more importantly here is what we call assured position navigation and timing, or APNT.
Wow, there's a lot there. So in terms of the business unit, you must make a lot of products, surely.
So we do. So the actual business unit that I lead, we're a little bit different than other business units at Microchip. There's 22 or so business units within Microchip. But for Aerospace and Defense Group, we're really a vertical marketing business unit. So instead of driving a specific product, we're driving a specific market. So we work with all the other business units within Microchip to bring products into the commercial aviation, space, and defense customers. My team typically includes product marketers, business development managers. We have an applications team. We got a team that will do a product test. We do radiation testing for various components. And we really help to work with the business units at Microchip that haven't necessarily been part of aerospace and defense in the past. And we help them bring their products into the A&D marketplace.
So that's fascinating. You're almost like a consultancy for the product divisions to help them actually enter this market space or serve the needs of the market space rather than being a division that creates products. That's kind of different.
It really is. It's a very innovative way for Microchip to help grow business and focus on strategic relationships. It's very similar to what Microchip does with the automotive products groups, or APGA, where they've also got a vertical team. But when you have the number of components that Microchip has, if you look at the number of devices, it's over 72,000 different components that we support and for high rel for aerospace and defense. So it's very unique.
I've got to ask, this is a bit of a cheeky question, but Microchip is seen as a supplier into the consumer and industrial sector. I think that's what everybody kind of knows the pick for. So how big are you in aerospace and defense? Are you a significant supplier, or is this something you're just trying to grow?
Well, so what most people don't know about Microchip is we're actually the number one semiconductor supplier for the aerospace and defense market. So that includes devices across the spectrum, from FPGAs to discrete products to timing solutions to RF. So it really is a large segment for us at Microchip. For the company, it makes up maybe about 10% of the overall revenues for Microchip. But we're very proud to hold the title that we have right now, and we believe as being the number one semiconductor supplier. We just want to continue to bring more products and deliver mission assurance, to support new applications in the A&D marketplace.
That's actually a real surprise that you are the largest semiconductor supplier into that market space. I'm sure a lot of people didn't realize that, and probably didn't realize that you're 10% of Microchip's business. How did you get into this position? Presumably some of it's, Microchip growing, some of it would be acquisitions.
Yeah, and it's important to understand the significant acquisitions that the Microchip has had over the past several years and many years. So we basically formed this team through several key acquisitions. So If you look at the number of acquisitions from the get-go, there's probably somewhere between 20 and 30 different acquisitions that Microchip has done. But the three key ones would probably be back in 2011, Microchip acquired a company in Thailand called Millennium Microtech, and it's what we call Microchip MMT today. And they were a provider of assembly and test services for the high-rel aerospace market. In fact, as we do testing for some of our competitors' product out of MMT. And then in 2016, when Microchip acquired Atmel was really very big in MCUs, but with that acquisition came Atmel Aerospace, which is located in France. That helped Microchip get their toes basically into aerospace and defense. And with that group, we have a lot of high reliability offerings. We have engineering that came in with that aerospace and defense group. We have the radiation specialties that came with that. So, and being able to do rad hard space ASIC design. So that was a very key acquisition. And then in 2018, which is how as I mentioned, how I came into Microchip acquired Microsemi. So, and if you look at Microsemi and what makes up Microsemi, which is now a part of Microchip, you look at the FPGA group, original Actel came in with that acquisition. Some of the other common names, Vectron, for example, and Symmetricom. These are all names that are out there in the A&D world that have all become part now of Microchip. So really some significant acquisitions that have brought a large number of companies together in under one umbrella to support aerospace and defense. And for us, for over 60 years, if you looked at all this, we've enabled missions and space missions from the very first satellites in the 1950s and 60s, all the way up to, into Apollo 11 back in the day, all the way up to what we would say today is a real drive for NASA and other space agencies around the world. ESA, for example, JAXA for the Artemis mission, which is bringing man back to the moon.
Hang on, you just said you've been there since Apollo 11, providing products all the way through to today?
That's correct.
I absolutely love this. I mean, one of the things I'm interested in, you have a term used called mission assurance, which obviously is something that, I think means something to people in the A&D market, perhaps doesn't mean so much to me. Can you explain that and explain what mission assurance is and why it's so important for your market?
Sure, yeah. To talk about mission assurance, it's probably first important to understand, that the aerospace and defense applications come with the need to withstand harsh environments. So harsh environments can include extreme temperature, for example, humidity, substantial shock and vibration. So for many aerospace and defense applications, from submarines to tanks, they've got temperature extremes that fall outside the normal commercial or industrial type ranges. And for these environments, you can see the need for electronic components that will work flawlessly from cold temperatures, -50 degrees, all the way up to 125 degrees Celsius. And you can also imagine the shock and the vibration environment around a tank in a battlefield, or even a fighter flying at Mach 5. So it's very important to have components that will withstand those environments. But in addition to that, you've also got a lot of avionic. I talked about commercial aviation. So you got avionic and space applications that not only have to consider those types of environments that I've just mentioned, but you also have the added effects of natural ionized radiation effects that can be very detrimental to electronics. The radiation effects are really a primary cause of electronic failure if they're not properly addressed in the manufacturing of the components. And so when we talk about mission assurance, the mission assurance is really a process of identifying and mitigating all the deficiencies that could threaten the success of a mission. And so the process really employs the methods to mitigate the deficiencies, starting with the design, to the production and test, and then finally the deployment phase, of the mission. And so it's really important that when customers are looking at products, that they select the products with the proper quality and reliability levels, in order to address these deficiencies. So that's where Microchip comes in. We can assure our customers they're receiving products that are intended to meet or exceed their mission requirements and the harsh environments that they may experience.
That's fascinating. And presumably that's what you're bringing to Microchip, that understanding of all these special requirements in aerospace and defense missions. And what you're trying to do is you're trying to help the different product divisions overcome them in those products. Have I understood that right?
Precisely. Exactly correct.
This is fascinating. And it's so interesting, Bob, to hear about how complex it is to design products for these markets. One of the things I hear from some other suppliers is that aerospace and defense is just too challenging. The volumes are too low. What's Microchip's view about the market? Are you in this for the long run? Is this something that Microchip see as a strategic part of the business? I mean, hopefully it is, because you're the biggest supplier in the market, but, tell me where you are.
Well, you talk about the long run, if we say we were shipping parts back in the 50s and 60s, it's obvious that Microchip is in it for the long run because we always look back at history. If you want to look and try to predict the future, you can look back at history. So I've seen in this industry a lot of companies come and go with respect to supporting aerospace and defense. They'll stick their toe in the water with it, and to the point you made with the volumes being lower, it requires a lot more handholding with customers, a lot more testing, and the volumes, as you say, are low. A lot of times the ASP of parts, because of the additional testing, that comes at a cost. So the ASPs are a little bit higher. But for Microchip, what we do to continue to be invested in the market is we're really looking at what we call a total system solution, or TSS. So where we may have an FPGA or an ASIC or rad tolerant 32-bit MCU or Ethernet 5, we basically look at what can we put around these parts and how can we build more of this total system using Microchip parts. So if you look at a typical system, you have interface chips like the Ethernet we talked about, the Ethernet 5s and whatnot. We talk about timing type products. You have clocks and the crystals and oscillators so you need timing around your part. You need power. So you have to be able to power all your devices. And so from a Microchip perspective, we try to continue to look and map out and continue to fill boxes all around what we call this anchor product or FPGA or ASIC or MCU with all the parts that are required to make the system work. And then you look at what some of the market forecasts are looking at. Everybody is looking at from a commercial aviation standpoint. You look at the two key airframers, their markets are growing substantially over the next 15 years or so. We're seeing a growth right now in defense spending across various nations of the world. And we're seeing a huge increase in space and the number of launches and the size of the constellations that are out there. And so really the future for aerospace defense is really bright.
So you mentioned radiation. Now, I think for people like myself a long time ago, I was an engineer in the industrial sector. We didn't worry about radiation, but clearly when you get into things like satellites, that becomes really important. Can you just explain why radiation is such an issue for your customers, and maybe perhaps even explain a little bit about what radiation does to ICs to make them fail?
Yeah, sure. Well, when we talk about radiation, we look at various types of radiation that can actually affect devices. So we break it down into a couple different groups, but we'll talk about a single event latch up or SEL. Single event latch up is basically when you can have an energy particle that comes in, it can hit a sensitive area of a device, which then could cause a high operating currents, or what we say the device to actually lock up. You can actually have a failure of a device where the device will no longer operate. You also have what we call a single event upset. And a single event upset is less damaging, but it can cause a bit slip, for example, something that in your circuit that would actually change the design of the circuit. So it's important that you look and measure and test for SEU, or single event upset. And then the third area I'd say is what we call total ionizing dose, or TID. And this is basically an amount of charge that can build up in a device over time that will eventually cause that device to failure through, it can fall out of spec with high currents, or, fail altogether. And that's more critical for applications that might be, have longer life expectancies, like 10 or 20 year missions, which some satellites have missions that are out to 10 to 20 years. So, and it's very key. It's, everybody thinks, well, radiation is kind of something that we just worry about in space. That's actually not true. Even at ground level, you get these high energy particles, and there's papers out there where various electronics have had problems and stuff at ground level. But more importantly for us in our avionics type designs is commercial aircraft or military aircraft. At higher altitudes, you have more of these particles, let's just say. So you have a more likelihood of a particle coming in and actually changing and doing something with your device. So for avionics, it's very important for them also to look at parts that have been tested and can work under these harsher environments.
So it's interesting. You talk about testing for radiation, but I mean, I hear two phrases when it comes to radiation tolerant and radiation hardened. And can you explain what the difference is between those two categories of parts and what those words mean, maybe?
Yeah, sure. So a radiation tolerant versus a radiation hardened device, it really has to do with the amount of radiation a device can withstand. From a radiation tolerant device, typically we're at 100K rads and below when we talk about something that's radiation tolerant. And for us to have a radiation tolerant device, we can build from a COTS, a COTS type device. We can build an RT, a radiation tolerant device, by doing things like making some tweaks to the process, in order to get acceptable levels of TID. In both cases, by the way, radiation hardened and tolerant, you can't have a device that will latch up. So the SEL, you must make sure that the device doesn't latch up. But a radiation hardened device is something that could be, withstand greater than 300K rads, for example, of total dose. And typically those devices are what we call as rad hard by design, which means you have to start back in the design phase and actually design the chip and the circuits within that chip, design them to withstand the radiation. An example of that might be putting error correction on memory, or ECC. It might also be building what we call triple module redundancy, where you multiply all the circuits, you build three gates and put a voting circuit in there on the 3 gates so that it's always the best 2 out of 3. And then using special libraries for a particular process that might be rad hard. So that's how we kind of differentiates between what we'd say is a rad tolerant and a rad hard device.
And presumably, I mean, you talked about having engineering expertise in your group. So your group is the engineers that can help, not only tweak that process to create the rad tolerant device, but also create the radiation hardened device as well from that initial design phase. I mean, that's what you're bringing to the product divisions, is it?
Yeah, that's correct. So with my group, what's nice is that, first of all, we've got the experience. So as part of product development, we throw into the product development the testing and radiation testing. A lot of companies don't necessarily do that because they're not concerned necessarily with this mission assurance. They're not looking at space or avionics type applications for their devices. But for Microchip and my team, we have the expertise on the team and built into our standard processes to do this testing. We also schedule test time on a regular quarterly basis at the various labs around the world. And by the way, we also have our own radiation test lab within Microchip. So these are a group of engineers that understand what we have to do when we take a device, how we have to put that device on a board, how we have to set that board up to run cables and whatnot, so we can take it and put it into the chambers for radiation test. So we have a specific engineering group specifically for radiation test. You put a whole wrapper around that really helps Microchip become this number one semiconductor supplier that we talk about.
And that's fascinating. It sounds like you're saying it's not just the design, but it's also the test. So, having your own, experts, but also having the MMT test facility must be a big benefit for your division.
Very much so. So yeah, so we can do that testing. But by the way, with all of these devices, whether they're rad tolerant or rad hard, you also have to have the ability to get your QML certification. So example, through the DLA, or in Europe through the SCC, and get the qualification. So not only do you need to have radiation expertise, but you also have to have your quality and your expertise there. It's just important that companies are able to provide that to the aerospace and defense market. And we're really good at doing that.
That's really exciting. And some of those products you mentioned, it sounds like actually a lot of pretty new technology is now going into this market. It's not all old, long-established technology. There's a lot of high tech. Is that right? I mean, do you have some new products you've launched that give that kind of idea of what's new and what's exciting?
Yeah, what's kind of interesting is we've learned over the last few years is a growth and Ethernet applications, believe it or not, across a lot of space and satellite type programs. We recently announced our VSC 8574 RT. It's a radiation tolerant gigabit Ethernet 5. It complements 2 other devices that we launched over the last couple of years, the VSC 8541 RT and the VSC 8540. So these parts are critical for applications today. 5 years ago, we wouldn't have even realized that Ethernet was going to be a key player in space applications. On the VSC 8574, for example, we talk about the latch up immunity. So we always talk about making sure that that part doesn't latch up, and it can withstand 78 MeV and total ionized dose testing up to about 100 Krad. So it's a very good solution, especially for low Earth orbit or LEO applications, but all the way into even deep space type applications. And then there's another coming soon. It's not launched now, but we do have a huge processor that will be coming to market, a high performance space compute processors through a NASA program. And we'll be driving that and pushing that out in the marketplace here over the next couple of years as well. So just some very exciting new applications that we haven't really been in before.
That's really cool. And it's great to hear there's more and more products coming. I love the idea of satellites with Ethernet networks running around them. I mean, that seems incredible, but at the same time, you can see why it makes sense. Do you have any other interesting or unusual applications where you've seen people do things that are perhaps a bit surprising?
I don't know if I've seen unusual applications necessarily. I'll tell you what, interesting though applications for us, and something that was very important for Microchip and actually as a NASA program. If you remember back in the 2021, so we basically had what's called the Mars 2020 program, where we had a rover, actually the Perseverance, land on Mars. And so if you look at everything from the launch vehicles to the Mars orbiter, to the Land Rover Perseverance. And then there's also a little helicopters, you remember, Ingenuity. Well, if you look at all that together, Microchip had components from, we had FPGAs from our FPGA BU. We had this high rail discretes from our high rail division. We had timing products, and we had MCUs from MCU 32. So you look at all the different parts, and we probably had somewhere between $10 to $12 million worth of product on that Mars program. And so it's very exciting when you can see the rover out there on, on the Martian surface, and even the videos that you've seen of the helicopter, to know that you've got devices and that you're part of that. That's probably like a more interesting type of applications that I would point out.
That's so exciting. Must have also been a little bit stressful whilst you waited for the rover to start communicating back as well.
Exactly right. You always wonder, hey, is it going to be successful? If it's not successful, why not? But we've got a lot of examples where our parts have just functioned flawlessly.
Yeah, and the rover's such an amazing story. I love that. As a geek, I think that's so exciting, Bob. Thank you for sharing that. I'm really mindful of your time. So I'd like to finish with asking everybody on this podcast series for a bit of engineering advice. So is there some engineering advice that you could give to, maybe someone who's in the aerospace and defense market?
Probably the best advice I could give is to make sure, and we've kind of covered this in the podcast as well, is make sure that you work with solutions from companies that you can trust. So you look at the companies who have heritage. You want to look at a company who understands what mission assurance is, and then from that list, pick the ones that you're confident that they're going to continue to invest in innovative products to support, the aerospace and defense needs. I'd probably say that would be the most important.
Yeah, and I think Microchip fits the bill. I mean, continuing to invest, bringing new products, and also the biggest supplier on the market. I think I've learned so much from this chat. I really appreciate it, Bob. Before I go, if people have questions or they want to keep up to date with Microchip and what you're doing in the aerospace and defense market, what's the best way for them to make sure that they know what's going on?
The best way probably is to visit microchip.com. If you go to the aerospace and defense webpage there, we've got quarterly newsletters, our space brief, and then an aviation and defense newsletter. You can subscribe to those and have them emailed to you on a quarterly basis. And with those comes all the latest updates of what we've got, interesting application notes, and designs that could be included. That can talk about new products that are available as well. And so I'd say that's probably the best place to go. And if somebody wants to reach out to me, they can find me at microchip.com as well. They can email me. Of course, I'm also on LinkedIn. But best place to go is to directly to our website, microchip.com.
That's amazing. Bob, I really appreciate it. It's been such an enjoyable conversation. Thank you so much for being on the podcast.
Thank you, Mike. It's been enjoyable. Thank you.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.